Hello and greetings. This is Dr. VC Sontake and I am the course faculty for the course Energy Conversion 3. In this video lecture, I am going to discuss about the atmospheric jet engines. They are also called as air breathing engines. So objectives of this video lecture are to explain construction and working principle of various types of atmospheric jet engines, particularly the turbojet engine. Now, in the previous lecture, I have discussed about the classification of various jet propulsion systems or jet engines. Here, I am reproducing the same classification for general discussion. So, jet propulsion systems or jet engines are classified as atmospheric jet engines or air breathing engines. In these atmospheric jet engines, atmospheric air is required for the combustion of the fuel in the jet engines, and that air is required from atmosphere. The atmospheric jet engines do not carry their oxygen with them. The second subclassification is rocket engines. They are also called as non-air breathing engines. The rocket engines carry their own oxidizer for the combustion of the fuel and is therefore independent of atmospheric air. And since they can carry their oxygen along with them, hence they can also travel into the space, which is not possible for air breathing engines. Atmospheric jet engines are further classified as steady combustion systems or continuous airflow. There are different types of steady combustion systems like turbojet with afterburner, turbofan, turboprop, also known as propjet, and ramjet. And the second subclassification of air breathing engine is intermittent combustion system or intermittent airflow. So pulse jet is the example of this type of jet engine. Pulse jet is also known as aeropulse, aerojet, cement tube, and intermittent jet. Rocket engines are further classified as solid propellant and liquid propellant type. Atmospheric jet engines or air breathing engines. So we are going to discuss in detail about the construction and working principle of various types of air breathing engines. So atmospheric jet engines are classified as steady combustion systems or continuous airflow system. In this type of category, there are turbojet with afterburner. They are also known as turbo ramjet, turbojet with tailpipe burning, and turbojet with reheater. Then turbofan, they are also known as fanjet, turboprop, also known as propjet, ramjet, also known as athodites. This is the acronym of aerothermal dynamic ducts and lorry tubes. Scramjet is the version of ramjet which moves at the supersonic speed. Then in the intermittent combustion system category, pulse jet, and it is also known as aeropulse, aerojet, cement tube, and intermittent jet. The turbojet the turbofan and the turbojet with afterburner and turboprop are all modified forms of the simple open cycle gas turbine, whereas ramjet and pulsejet are aethodites, aerothermodynamic ducts, that is, straight duct types of jet engines without compressor and turbine wheels. In the turbojet, turbofan, turbojet with afterburner and turboprop. In all those jet engines, they are basically consisting of all the components as in simple gas turbine cycle, whereas in ramjet and pulsejet, compressor and turbines are not there. So that is the basic difference between these types of jet engines. Now, ideal jet propulsion cycle. So every jet propulsion system is supposed to work on a cycle. So what will be that ideal jet propulsion cycle, or what are the characteristics of this ideal jet propulsion cycle? So jet propulsion systems or aircrafts extensively use gas turbine engines to power them because they are light and compact and have a high power to weight ratio. Aircraft gas turbines operate on an open cycle called as jet propulsion cycle. Aircraft gas turbine cycle differs from the shaft power cycle in that net power output of the jet propulsion cycle or aircraft cycle is in the form of thrust. We won't get any power output from aircraft gas turbine cycle. Rather, the entire output will be in the form of thrust. The ideal jet propulsion cycle differs from the simple ideal Brayton cycle in that the gases are not expanded to the ambient pressure in the turbine. Instead, they are expanded to a pressure such that the power produced by the turbine is just sufficient to drive the compressor and the other auxiliary equipments such as a small generator and hydraulic pumps. That means the net work output of a jet propulsion cycle is zero. So that is the major difference between the jet propulsion cycle of aircraft or jet propulsion cycle and simple gas turbine cycle. The gases after exiting the turbine at a relatively high pressure in the jet propulsion system are subsequently accelerated in a nozzle to provide the thrust to propel the aircraft. Also, aircraft gas turbine operates at a higher pressure ratio, typically between 10 to 25, whereas for simple gas turbine this pressure ratio is from 8 to 12, and the fluid passes through diffuser first, where it is decelerated and its pressure is increased before it enters the compressor. So after discussing the various basic points about the air breathing engines and the cycle or jet propulsion cycle, now let us start discussing about the various types of jet engines. So all the jet engines have common principle and basic operations. So the first operation in all the jet engines is intake. In this, atmospheric air enters through the intake duct. This duct slows down the incoming air and removes distortions. In many of the jet engines, this duct is actually in the form of diffuser. So diffuser reduces the kinetic energy of the incoming air and increases pressure energy. Compression. In this process, air is compressed by passing through the compressor, and the compressor dynamically compresses the air. Then combustion process, where compressed air is mixed with fuel in the combustion chamber. Fuel is ignited and that heat addition takes place through chemical reaction. And pressure and temperature of the gas are raised. Extremely sorry, during combustion process, pressure is not raised. Pressure remains constant. Generally, during the combustion process, heat addition takes place at constant pressure, and because of this heat addition, temperature of the gases are raised. So please correct this. Only temperature of the gas is raised. Expansion. During this process, run the compressor. Some of the pressure of the gas used to turn a turbine by expansion into it. So during this process, what happens? Gases are expanded to a pressure to produce work output just sufficient to drive the compressor. Turbine shaft drives the compressor. Then nozzle or free turbine expansion process. During this process, generation of thrust power or shaft power by expanding high pressure gases into nozzle. And while expanding in the nozzle, the gases are coming out of the aircraft at very high velocity in the form of jet. This gives rise to thrust to propel the aircraft in the forward direction. Now, out of these 5 processes, depending upon the type of jet engine, one or the other process may be applicable or not. But these are the general processes which are supposed to take place in any jet engine. So let us discuss the very first type of jet engine is turbojet engine. So its construction of a turbojet engine is shown in the diagram. The typical turbojet engine consists of following components: diffuser, compressor, combustion chamber, turbine, and propelling nozzle. The compressor is connected to the turbine through a shaft. So these are the general components of turbojet engine. And all these components are covered by a duct. So let us discuss the basic operating principles of turbojet engines or various processes taking place in a turbojet engine. The various processes taking place in a turbojet engine are shown on temperature entropy diagram, and also they are shown in the individual components in the figure 2. So this diagram represents the processes on TS diagram, and figure 2 represents the different processes taking place in the respective components. So sequence of operation in the turbojet is as follows. The very first process is air intake process 1 to 2. It is represented on TS diagram by a vertical line because ideally this process is considered as an isentropic process, and this process takes place in the diffuser from 1 to 2. So in this process, atmospheric air is entered through diffuser where its pressure rises slightly as the air is decelerated in the diffuser. This process of slight rise in the pressure of air by diffuser is called as ram compression. When incoming air enters into the diffuser increases the pressure energy at the expense of kinetic energy of incoming atmospheric air during the process 1 to 2, and this is called as ram compression. Please mind well the word ram compression. Compression process 2 to 3, it is represented by vertical line on the TS diagram, and it takes place in the compressor from 2 to 3. During this process, air pressure and temperature are increased by multi-stage compressor in the compressor. And ideally, this process is also considered as isentropic. So it is represented by vertical line. Combustion process 3 to 4. It is represented on TS diagram by a curved line, and it takes place in the combustion chamber from 3 to 4. During the combustion, combustor adds fuel to the air and burns the mixture at constant pressure to increase the temperature, and energy levels are increased to a further level. So this process is an isobaric process ideally. Pressure remains constant, only temperature of the gases are increased. Expansion process 4 to 5, it is represented by vertical line, and it takes place in the turbine from 4 to 5. So during this process, the high pressure and high temperature gases are partially expanded in the turbine. Turbine produces enough power to drive the compressor and other accessories via a shaft. And ideally this process is also considered as isentropic process. Hence it is represented by a vertical line. Final expansion process 5 to 6. It is also represented by vertical line, since it is also supposed to be isentropic process, and this process takes place in the nozzle from 5 to 6. So during this process, finally the high pressure and high temperature gases are expanded in a nozzle to the ambient pressure and leave the engine in the form of jet at very high velocity, and this high velocity produces thrust on the engine from the Newton's third law of motion, and this third thrust propels the engine in the forward direction. So this way the turbojet engine works. So this is the working cycle of turbojet engine and different processes in the turbojet engine. Now, salient points about the turbojet engine. All the intake air passes through the combustion chamber and exits through the nozzle. In case of turbojet engine, whatever incoming air is entering through the diffuser, that is made to pass through the different components and finally leaves the turbojet engine in the form of jet. Not any single percentage of air is bypassed. What is bypassing of air, we will be discussing in the subsequent jet engines. In turbojet engine, the whole turbine power output is consumed by compressor, and hence there is zero shaft output power. The sole output of any jet engine is its thrust. The aircraft is wholly propelled by the jet thrust, high pressure, high velocity jet. All the thrust of a turbojet engine is due to the exhaust gases, leaving the engine at about twice the speed of a sound. And this high speed jet causes significant noise generated by the turbojet. So because high pressure and temperature gases are leaving the nozzle in the form of jet. So this generates a significant amount of noise in case of turbojet. That is why turbojet engines are very noisy in operation. A turbojet engine has a relatively high specific fuel consumption at low flight Mach numbers and low altitudes and requires a long takeoff roll. However, it has a low weight to thrust ratio and a small frontal area. Because of this reason, turbojet engines are always recommended to operate at high altitudes at and with high velocity. Jet engine run airplanes can save fuel by flying at higher altitudes during long trips since air at higher altitudes is thinner and exerts a smaller drag force on aircraft. This is another reason to fly the jet engines at higher altitudes, so that drag force will be minimum on the aircraft, so this will increase the fuel economy. Less power will be consumed to overcome the drag force. Now increase in the flight speed improves the performance of jet engine because of the benefit of high ram pressure achieved by diffuser. So more will be the velocity of the jet engine, more will be the velocity of the incoming air into the diffuser, and diffuser will convert this kinetic energy into pressure energy. So there will be more ram pressure by ram compression in the diffuser. Applications of turbojet engines. Turbojets have poor efficiency at low vehicle speed, which limits their usefulness in the vehicles other than aircrafts. They are not recommended for surface vehicle applications. However, they are used in some of the cruising missiles and MiG-25 aircraft. So learning outcome of this video. At the end of this video, learner will be able to explain construction and working principle of various types of atmospheric jet engines or air breathing engines, and will be able to explain the construction and working of turbojet engine. In the next lecture, I am going to explain the modifications in turbojet engine. So based upon this modification, there are two variants of turbojet engine with afterburner and turbofan. So these are the two variants of the turbojet engine, and their construction and working I am going to explain in the next lecture. So with this, I come to an end of this video lecture. Thank you for your passionate listening and kind attention. Happy learning.